We are going to start with lecture 4, that is 6.6. Deals with inverse trigonometric functions. Inverse trigonometric function. Say sine inverse x is the inverse function of sine, but we have restrictions on the domain and the range. Sine inverse x domain is negative 1 to 1, and the range is negative pi over 2 to pi over 2. Its derivative is 1 over square root of 1 minus x square. We will see the derivation in a minute. Cos inverse x, it is domain is negative 1 to 1, and the range is from 0 to pi, and f prime x is negative 1 over square root of 1 minus x square. Tan inverse x, its domain is negative infinity to infinity, and range is negative pi over 2 to pi over 2, excluding the boundaries. Whereas in the case of sine and cosine, the boundaries are included. Here it is parenthesis, not bracket. Derivative is 1 over 1 plus x square. Cot inverse x, negative infinity to infinity, 0 to pi, negative 1 over 1 plus x square. Secant inverse x, we don't care about the domain and range because it is slightly complicated. Its derivative is 1 over x times square root of x square minus 1. And finally, cosecant inverse x, domain, forget about the domain. The derivative is negative 1 over x times square root of x minus 1. Okay, so now there is a very important result that I missed here, that I'm going to write it. See, this is a result. Sin x is equal to y implies x is equal to sin inverse y. So you have to keep this in mind. If sin x is equal to y, then x is equal to sin inverse I, and the converse also is true. If x is equal to sin inverse y, then y is equal to sin x. Okay. Now you have the antiderivatives, because these are the derivatives. So antiderivative of 1 over square root of 1 minus x square is sin inverse x. Antiderivative of negative 1 over square root of 1 minus x square is cos inverse x. Antiderivative of 1 over 1 plus x square is tan inverse x. Antiderivative of, sorry, did I say something wrong? Antiderivative of 1 over 1 plus x square is tan inverse x. Antiderivative of negative 1 over 1 plus x square is cot inverse x. And antiderivative of 1 over x times square root of x square minus 1 is secant inverse x. And that of negative 1 over x times square root of x square minus 1 is cosecant inverse x. Okay, now we are going to derive this formula. Differentiate sin inverse x, that is, find the derivative of sin inverse x. So you start like this. Let y is equal to sin inverse x. Therefore, x is equal to sin y. And so dx over dy is equal to cos y, that is square root of 1 minus y square, 1 minus sin square y, because that is the trigonometric equivalent of Pythagorean theorem. Cos y is equal to square root of 1 minus sin square y, and therefore dx over dy is square root of 1 minus x square. Sin y is x square, and Therefore, dy over dx is 1 over square root of 1 minus x square. Second, cos inverse x. Y is equal to cos inverse x. Therefore, x is equal to cos y. Therefore, dx over dy is negative sine y. That is negative square root of 1 minus cos square y. Dx over dy is equal to negative square root of 1 minus x square, because cos y is the same as x. So dy over dx is equal to negative 1 over square root of 1 minus x square. Then number 3, y is equal to tan inverse x. Therefore, x is equal to tan y. So dx over dy is equal to secant square y. That is equal to 1 plus tan square y. That is another variation of the trigonometric equivalence of the Pythagorean theorem. Secant square y is 1 plus tan square y. So dx over dy is 1 plus x square, because x tan y is the same as x. And dy over dx is the reciprocal of that. That is 1 over 1 plus x square. Fourth one, cot inverse x. Y is equal to cot inverse x. So x is equal to cot y. Dx over dy is negative cosecant square y. You please recall these results from calculus 1. And negative of 1 plus cot square y. That is again result from trigonometry. Dx over dy is equal to negative of 1 plus x square, because cot y is the same as x. That is dy over dx is negative 1 over 1 plus x square. Secant inverse x. Y is secant inverse x. So x is secant y. Dx over dy is secant y times tan y. And tan y is secant square y minus 1. Square root of secant square y minus 1, because tan square y is secant square y minus 1. So secant y times square root of secant square y minus 1. That is the same as x times square root of x square minus 1. Therefore, dy over dx is the reciprocal of that. That is 1 over x times square root of x square minus 1. Next one, y is equal to cosecant inverse x. So, x is equal to cosecant y. Dx over dy is negative cosecant y times cot y. Result from calculus 1. That is negative cosecant y times square root of cosecant square y minus 1. And that is negative x times square root of x square minus 1, because x is a cosecant y. That is equal to, dy over dx is equal to negative 1 over x times square root of x square minus 1. Okay, here we start the some integration, some standard integration. Integral 1 over square root of a square minus x square dx. This is a standard result. You have to memorize the results. So we are going to derive that result. You substitute x is equal to a sine theta. Whenever you have square root of a square minus x square, the substitution is x is equal to a sine theta. Therefore, dx is equal to a cos theta d theta. So a square minus x square, because there is an a square minus x square here. A square minus x square is a square minus a square sine square theta. That is a square times 1 minus sine square theta, factoring out a square. That is a square times cos square theta. So this integral is equal to integral dx a cos theta d theta, a square minus x square, a square cos square theta in the denominator. So square root of a square cos square theta is a cos theta cancels, a cancels. So you get integral d theta, which is theta plus c. Now what is theta? So x is a sine theta. So sine theta is x over a, where you divide both sides by a. Sine theta is x over a means theta is sine inverse x over a. So theta is sine inverse x over a. The answer to that integral is sine inverse x over a plus c. number 8. Here there is no square root, 1 over a square plus x square. So whenever you see a square plus x square, you use the substitution. X is equal to a tan theta. Differentiate that, you get dx is equal to a secant square theta d theta, because derivative of tan theta is secant square theta. That is a square plus x square is a square plus a square tan square theta is equal to a square times 1 plus tan square theta. 1 plus tan square theta is secant square theta. So that is a square secant square theta. Therefore, under derivative of 1 over a square plus x square dx is equal to integral dx. Dx is a secant square theta d theta. Denominator a square plus x square, that is a square secant square theta. Secant square theta cancels, 1a cancels, that is 1 over a d theta. So 1 over a times theta plus c. And now what is theta? X is equal to a tan theta. That is tan theta is equal to x over a. Therefore, theta is equal to tan inverse x over a. So the final answer is 1 over a tan inverse x over a plus c. So these are the two very important results that you are going to use throughout this course and also in calculus 3. So integral 1 over square root of a square minus x square dx is sine inverse x over a plus c. 1 over integral 1 over a square plus x square dx is 1 over a tan inverse x over a plus c. See, notice in the case of sine inverse, there is no 1 over a. In the case of tan inverse x over a, there is a 1 over. Now, this is a question from the textbook. Differentiate, number 22. Differentiate y is equal to tan inverse x square. Y is equal to tan inverse x square. So dy over dx. First you use the formula for tan inverse. Derivative of tan inverse x is 1 over 1 plus x square. So this is going to be 1 over 1 plus x square square. Now differentiate this x square with respect to x. You get a 2x, that is times 2x. So this is chain rule. You differentiate using the formula for tan inverse, and then once you do that, you take away the tan inverse, you have x square. Differentiate x square with respect to x, that is 2x. So the answer is 2x divided by 1 plus x to the 4. 24, gx is equal to cos inverse square root of x. So g prime x is equal to negative 1 over square root of 1 minus square root of x square times 1 over 2 times square root of x, because this is the derivative of square root of x. And here you use the formula for cos inverse x. Negative 1 over square root of 1 minus square root of x square times derivative of square root of x, that is 1 over 2 times square root of x. So rearranging the terms, you get g prime x is equal to negative 1 over 2 square root of x times square root of 1 minus x. Square root of x square is x. So that is the answer. 26. Sine inverse 1 over t. Differentiate. First you use the formula for sine inverse function. R prime t is equal to 1 over square root of 1 minus 1 over t the whole square times derivative of 1 over t is negative 1 over t square. Now differentiation part is over. Now a little algebra is here. So it is going to be negative 1 over square root of 1 minus 1 over t square times 1 over t square, and that is equal to negative 1 over t square minus 1. That is, this is t square over t square 1. So t square minus 1 whole divided by t square under radical sign times 1 over t square. So that is equal to this derivative of, square root of t square is t, and that is the denominator of the denominator. So that goes into the numerator. So it is a t, and then 1t cancels. There remains a t in the denominator. So the final answer is negative 1 over t times square root of t squared minus 1. In this case, differentiation is easy, but there is a little algebra. So next is 28. Cos inverse of sine inverse t. First, you have to use the formula for cos inverse function. Then you use the formula for sine inverse function. So dy over dt is negative. Cos inverse has a negative, derivative has a negative sign. 1 over square root of 1 minus sine inverse t the whole square. Now you multiply this by the derivative of sine inverse t, that is 1 over square root of 1 minus t square. And that is the answer. There is no change in there. Okay. There is no simplification possible. 32. Y is equal to tan inverse x minus square root of 1 plus x square. And here also, the differentiation is not difficult, but algebra is a little difficult. So 1 over 1 plus x square, that is a formula for tan inverse x. So here it is 1 over 1 plus the argument square. So x minus square root of 1 plus x square square. Now you have to multiply that by the derivative of x minus square root of 1 plus x square. That is 1. Derivative of x is 1 minus, again applying chain rule here, 1 over 2 times square root of 1 plus x square. You use the formula for square root, multiply that by the derivative of the radicand, that is the expression inside the radical sign. So it is 0, derivative of 1 is 0, x square is 2x, 2 cancels, and now you FOIL this 1 over 1 plus x minus square root of 1 plus x square the whole square. So you are going to use the formula for a plus b, no, a minus b the whole square. So a minus b the whole square is a minus b the whole square. What you have to do is, if you do not know the formula, what you have to do is you write it as a minus b times a minus b. And now you FOIL and then combine like terms. When you FOIL, you get a times a square minus ab plus b square. That means a square minus 2ab plus b square. So a minus b the whole square is a square minus 2ab plus b square. You are using that formula here. That is 1 plus square of x minus 2 times the product of these two plus square of the second, that is 1 plus x square. 1x square cancels, and then you get 2 minus 2x times square root of 1 plus x square times square root of 1 plus x square minus x divided by 1 plus x square. Okay, so that is the answer. Now you have 36 sine inverse e to the x. So first you use the formula for sine inverse x, that is 1 over square root of 1 minus e to the x the whole square. Now multiply that by the derivative of the argument e to the x. E to the x derivative is e to the x itself, and so that is equal to e to the x divided by square root of 1 minus e to the x the whole square is e to the x times 2, that is e to the 2x, and that is the answer. Number 44 is a limit problem. So you have to find the limit as x approaches infinity, cos inverse of 1 plus x square divided by 1 plus 2x square. That is equal to, what you have to do is, first you divide each term inside the parenthesis by x square, the highest degree term. So you get 1 over x square plus x square over x square divided by 1 over x square plus 2x square over x square. And now that becomes limit x approaches infinity, cos inverse 1 over x square plus 1, because x square over x square is 1, divided by 1 over x square plus 2. When you substitute x is equal to infinity, you get 1 over infinity, which is 0. So first 1 over x square is 0. This also is 0. So that is cos inverse 0 plus 1 over 0 plus 2, which is cos inverse 1 half. And cos inverse 1 half is pi over 3. Again, for the test, you may use a unit circle. And if you look at the unit circle, cosine pi over 3 is 1 half. Therefore, cos inverse 1 half is pi over 3. Next. Limit x approaches 0 plus tan inverse logarithm of x, natural logarithm of x. And you see, look at the graph of natural logarithm function. Y is equal to natural log of x. See the graph? As x approaches 0 plus means it is coming from the right. Y is going indefinitely down. So it is negative infinity. So you may consider natural log of 0 as negative infinity. So this is tan inverse negative infinity. Tan inverse negative infinity is pi over 2. So again, you can see, if you are not sure about that, you can look at the graph of tan inverse x. So y is equal to second tan pi over tan x, second tan x, and I want to change the limit for the window a little bit. Here for y, I'm going to take pi over 2 as the limit, as the scale. Y minimum is negative pi. See, this is negative pi over 2. Next scale is negative pi over 2. So in the long run, as x approaches negative infinity, tan inverse becomes negative pi over 2. So the limit is negative pi over 2. 60. This is an integration question. Integral negative 1 half to 1 half 6 divided by square root of 1 minus p square dp. And 6 is a constant, you pull out 6 and then square root of 1 over square root of 1 minus p square is sine inverse p. So substitute the limit 6 times sine inverse 1 half upper limit minus sine inverse negative 1 half, that's the lower limit. Sine inverse 1 half is pi over 6. As I mentioned earlier, you may use the unit circle if you don't know the result, minus negative pi over 6, and that is equal to pi over 6 plus pi over 6. Distribute that 6, you get pi plus pi, answer is 2 pi. So that is answer to number 62. Integral 0 to square root of 3 over 4 dx over 1 plus 16x square. In this case, what you have to do is first you pull out a 16 from the denominator. So pulling out means you have to divide each term by 16. So write a 16, then you divide each term by 16. It becomes 1 over 16 plus x square. In other words, if you distribute 16, you get 16 times 1 over 16, that is 1, plus 16x square. So first step is pull out that 16. And that 16 is a 1 over 16 that goes out. And then 1 over 16 is written as 1 over 4 whole square plus x square. Now you recall the formula for 1 over a square plus x square, which is 1 over a tan inverse x over a. So this is 1 over 16 times 1 over 1/4 tan inverse x over 1/4. So this 4 cancels with the 16. That becomes a 1/4. And then this is the same as 4x, because when you divide by a fraction, you have to multiply by the reciprocal. So multiplying by 4, you get 4x. Now substitute the limits. 1/4 times tan inverse 4 times square root of 3 over 4 minus tan inverse 0. So 1/4 times tan inverse square root of 3 minus tan inverse 0 is 0. And the tan inverse square root of 3 is 60 degree, which is pi over 3. Again, if you don't remember that formula, you may use your calculator. But this time, you have to keep the calculator in the degree mode. Otherwise, numbers are irrational numbers. So you keep the calculator in the degree mode and then find tan inverse square root of 3. So second tan square root of 3 which is 60 degree. 60 degree is the same as pi over 3 radians. So 1 over 4 times pi over 3. So that is pi over 12. This was number 62, 64. Integral 0 to pi over 2 sin x divided by 1 plus cos square x dx. You know the derivative of cos x is negative sin x. So the substitution is u is equal to cos x. U is equal to cos x, du is equal to negative sin x dx. So sin x dx is equal to negative du. And now replace integral. X varies from 0 to pi over 2. Negative sin x dx is negative du divided by 1 plus u square. And so antiderivative of 1 plus u square is tan inverse u. So this is negative tan inverse u. X varies from 0 to pi over 2. So you replace u by cos x. So this is negative tan inverse cos x. X varies from 0 to pi over 2. Substitute, pull out the negative sign. Now you substitute upper limit tan inverse cos pi over 2 minus tan inverse cos 0. Cos pi over 2 is 0 and cos 0 is 1. So this is negative tan inverse 0 minus tan inverse 1. Tan inverse 0 is 0 and tan inverse 1 is pi over 4, 45 degree. Again, you can, if you don't remember, you may use the calculator. And then the radian equivalent of 45 degree is pi over 4. So negative of negative pi over 4 is pi over 4. Number 66. 1 over x times square root of x square minus 4. So first you substitute x is equal to 2u. X is equal to 2u. Dx is 2 du. So dx is 2 du. X is 2u. Square root of x square is 4u square. Yeah, I simplified it here. 4 times u square minus 1. X square minus 4 is 4u square minus 4, which is 4 times u square minus 1. So that is 2 cancels. Then you have a square root of 4, which is 2 in the denominator, times du over u times square root of u square minus 1, which is secant square u. So it is 1/2 times secant square u plus c, and that is u is the same as x over 2 because x is 2u, u is x over 2, and so answer is 1/2 secant inverse x over 2 plus c. Number 68. Integral e to the 2x divided by square root of 1 minus e to the 4x. E to the 2x here, e to the 4x here. E to the 4x is the same as e to the 2x the whole square. So the substitution is e to the 2x. U is equal to e to the 2x. Du is equal to differentiate e to the 2x times 2 dx. That is 2. Now you divide both sides by a 2. E to the 2x dx is equal to du divided by 2. So e to the 2x dx is du divided by 2. And then denominator square root of 1 minus u square. E to the 4x is e to the 2x the whole square, that is u square. And now 1/2 is pulled out. This is sine inverse u plus c, and u is e to the 2x. So the answer is 1/2 times sine inverse e to the 2x plus c. Okay, so okay, there ends lecture 4.